Okay, hi everyone. So this will be our third lesson for the chapter Discrete Random Variable. Okay, so I hope that by this time you must make sure that you have already gone through the previous two lessons so you know that what we are talking about in this lesson. Okay, so for the previous lesson we learned about what is discrete random variable, how to create and how to calculate the respective probability for the discrete random variable and to create a probability distribution. And for the last lesson we learned that how to find out what is the expectation, which is the mean, and what is the variance of a discrete random variable. So for the next four lesson, what we will try to do is we will cover up the two distribution in discrete random variable. Okay, so you can see the learning outcome for today is how to use the formula for probability for the binomial distribution and to recognize what is the situation where you can use the model or the distribution. Okay, so the same thing in the binomial distribution, you have also expectation and variance, which we'll cover in the next lesson. So today we'll be focusing on the, because I do not want to like split these two because they are interrelated to each other. So that's why I put them together. But then for today's lesson, we are going to cover only the first one. So for the next class on Wednesday, we'll be covering for the second part. Okay, so basically what we have learned before is we learn what is discrete random variable. So under discrete random variable, right? Okay, so under discrete random variable, you have actually two distribution that you need to learn. I mean, there is a lot more, but then in your S1, you are just going to learn these two. So which is the first one is called as binomial distribution. Okay, so the second one, distribution. All right, yeah, so the second one will be called as geometric distribution. Okay, so we will be using two lessons to cover up for the binomial and another two lessons for geometric. So today we'll start from binomial first. Okay, so what is a binomial distribution? So I already put in all the notes here that you can read through by yourself, but I'm just going through once together with you. Okay, so basically before you learn what is binomial distribution, you need to know what is that mean by Bernoulli's experiment. Okay, so the idea is actually very easy. A Bernoulli's experiment is basically an experiment with two outcomes. So meaning that it's either A happen or B happen. For example, the question like whether it rains or not today. So you can have like yes it rains, no it doesn't rain. So whether the student is a boy or a girl, so either the first one is a boy, the second one is a girl. Then tomorrow is your birthday or not, yes or no. So like you only have two outcomes, you do not have anything other than that. Okay, but I mean for the previous exercise and so on, you realize that there's a lot of experiment that you cannot have like only two outcomes. For example, when we try to throw the dice, so in this case normally the question or the experiment, they will try to group the outcome together to become two categories. So for example, instead of doing the probability getting 1, 2, 3, 4, 5, 6, which will have 6 outcome, then what we try to do is like the probability getting an odd number is the outcome 1. Probability of getting an even number is outcome 2. Okay, then it become only 2 outcome. So the other case will be like, for example, if I want to find out what is the probability getting of 5. So getting 5 is outcome 1. So other than getting number 5, which means I get 1, 2, 3, 4, 6, which is all under category 2. Okay, so for Bernoulli's experiment, what do you need to remember is like they only can produce 2 outcomes. So any experiment with only 2 outcomes is known as Bernoulli's experiment. So inside between the 2 outcomes, right? So basically we will try to define it as success and failure. Okay, what is that mean by success? Success is basically like an event that you prefer to happen. So for example, I want to state this like very clear that there is no clear definition or not clear definition. There is no negative or positive when we talk about success and failure. So for example, if today I want to find out what is the probability for a student that always late to the class, so there are two outcomes. Either she come on time or the other one she comes late. So if I want to find out the probability that she is late, meaning that I am interested to know what is the probability that she is late, so I will put the success as she is late to the school. So that doesn't mean that success must be a positive event and failure must be a negative event. It's basically success is the event that we want to find out or we are interested to know. But you see, in one experiment there's only success and failure, so it's totally alright like which one you define as success and failure. You are still getting the same answer even though even though maybe like person A, they try to say that the people late to the event that the student late to the school is success, then people B maybe do it in an experiment that for the success is like she comes on time to the school, but the probability itself will still be the same. But normally we try to state like success as an event that we want to investigate or the event that we prefer it to happen. So probability for success, we will try to denote it as P. Okay, for example, if the chances for the student who is late to school is like out of like, so 100%, 20% of the probability that she will be late. So 20% or like 0.2 is the success. Okay, so if 20% she will be late, so meaning like 80% she will be on time. So that's why the failure is like Q. How do you find out the Q? It's like from 0.2 you will use 1 minus it, right? So failure is basically equals to 1 minus P. Meaning that for the probability that the success doesn't happen is basically the complement for the set of the success. So that's why Q equals to 1 minus P. Or in another word, meaning success plus failure, you should able to get 100%, which is 1. Okay? So this is a Bernoulli's experiment. So when we try to, for Bernoulli's experiment, right, we try to only focus it in one experiment, meaning that if you throw the dice, that meaning I only throw the dice once, so which is Bernoulli's experiment, a single experiment. So now if we try to repeat the experiment with like several trials, so meaning that instead of throwing the dice like only once, then I try to throw it like I want to do the experiment like 5 times, 6 times and so on. When I repeat a Bernoulli's experiment, then the experiment will call as binomial experiment. So for a binomial experiment, right, the probability that you actually produce from this experiment will produce a binomial distribution, which is what we want to discuss today. Okay, so for binomial distribution, normally we will try to denote as the discrete random variable is a binomial distribution with n and P. Okay, so just now we already said what is P, right? Meaning the probability of it getting a success is a P. So N is basically how many times you repeat your experiment. Meaning if I throw the dice 6 times, meaning that my N will be 6. Okay, so you see, when the Bernoulli's experiment is repeated n times independently, so that's why the experiment is called as binomial experiment. Okay. So before we move into how to what is the formula for a binomial experiment, I want to talk about this first. So what is a constraint for a binomial distribution? Like you have plenty ways that you have learned, like whether it's conditional one, whether it's independent one, whether it's intersection and so on. So what is that special about binomial distribution that we will try to acknowledge like this event is a binomial distribution. Okay, so the idea is like there must be a fixed number of independent trials n. So meaning that if I want to throw the dice for 6 times, so meaning I have a fixed n which is 6. Okay, so the second one is each trial must have only 2 possible outcomes, which what I have explained just now. You can only have 2 outcomes. So meaning in the event that you want to find out the probability for the dice to get 1 times 2, 1 times 3, 1 times 4, then you cannot use binomial distribution because you have more than 2 outcomes already. Okay, so each trial must only have 2 possible outcomes when you want to say that it's a binomial distribution. Okay, then the next one is, since the trial is independent, right? So all the probability for the outcome in each trial must be constant. So if you were to refer back like what we have learned before in independent event, I think we learned 2 types of like tree diagram. So the first one is like when you try to do the thing with replacement and without replacement. So for replacement, right, for every time you will still get the same probability. So without replacement, then your sample space will reduce, the event maybe will reduce also. So but for this one, it must be independent, then only you can say that it's a binomial distribution. Okay, so I hope that you can like understand, you have a little bit idea for this before we move on, but it's actually a very easy thing that you can understand it like quite good. Okay, so alright, so let's move on this. So when you look at your second page, then you need to do it together with me. So I'll try to explain the formula for distribution, for the binomial distribution, so that you can understand how the formula come from and you do not find it like so confusing when you want to use it. Okay, so in an experiment, a coin is thrown. So the probability of getting a head is P and the probability getting a tail is Q, which is 1 minus P. So meaning in this event, we try to say that the X, or like the success here, the event success that we try to define here is basically the event getting the head. Okay, so let's say, so for this one we try to do some derivation for your formula, so that's why I don't want to use like 1 over 2 and 1 over 2, because you can't differentiate like which 1 over 2 is belong to the head, then which 1 over 2 is belong for the Q. So for all the working that we are going to do here, probability getting a head, we try to set it as P. Probability that getting a tail, we try to set it as Q. Okay, so now for the first one, we try to do a tree diagram first, so you can understand like what are we going to do in the next. Okay, so if the coin is thrown twice, so meaning that for every experiment that you do, every trial, you should able to get a head and a tail. Okay, so it start with that. So for the first time, maybe you get a head, maybe you get a tail. So the probability for head to happen is basically it's basically P. So meaning the probability of success to happen. Okay, so for T is Q. So meaning when we said that head is the success, meaning tail is the failure. Okay, so after I throw it for the first time, then I'll continue for the second time. So for a second time, I might continue to get a head, I might continue to get a tail. So the same thing, I might continue to get a head, I might get a tail also. So I have the P here, I have Q here also, and a P here and a Q here. Okay, so you can see that in this event, right, it's basically an independent event. So what happened in the first round or in the first trial, it doesn't affect your probability or the outcome in your second trial. So like whether you throw it is a head or a tail, it doesn't affect whether it's a head or a tail in your second round. Okay, so now this one, we try to do a bit of your probability distribution, which what you have learned previously. Okay, so let X be the number of success. In this case, is like number of getting a head here. So what is the possible outcome for your X? It's like either you can have 0 head, or you can have 1 head, or you can have 2 head. Correct? So yeah, refer back to the probability distribution that you have learned before. Okay, so these are the 3 possible outcomes. Okay, so if the number of success or the number of getting a head is 0, meaning that for 2 times I'm getting a head. So how do I get 0 success? Is like the possible outcome is like TT. So the first time is tail, the second one is also tail. For me to get R equals to 1, meaning 1 head, so meaning I can be TH and I can be HT. Is that okay? So I get one head, this is 0 head. So for me to get 2 head, meaning that for 2 times when I toss the coin, then I should be able to get HH also. Okay, so you see how many number of ways that I have here. I have only one, which is first one I must get a tail, second one I must get a tail also, so one way. So first, for me to get one head, I can have first time I get a tail, second time I get a head, or the first time I get a head, second time I get a tail, which is 2. For me to get 2 times of head, I have only one way, which is first time head, second time also head. Okay, alright, we just leave the answer here. This one later we try to put it in together. Okay, so what is the probability here? So what is the probability for you to get a T? Is Q. What is the probability for you to get another T? Is QQ. So normally you will use Q times Q, right? So this one give you Q square. So the probability for you to get tail or like 0 head is basically Q square. Okay, so now for the probability for the second one. So I have tail and head, meaning it's QP. Then I have head and tail, which is PQ. So PQ and QP, when you times them together, is still the same, which is PQ. But you have 2 ways here, so meaning you will times 2, you will plus them together. So meaning PQ plus PQ, then you are getting 2 PQ. Okay, I hope that you are with me. Okay, maybe we write it for the first time. PP, so this one you get P square, so PQ. So HT, you get PQ. TH, you also get PQ, and then TT, you get Q square. So when you want to find out for the x equals to r, then you will use PQ plus PQ together, which give you 2 PQ, right? Or it's basically like you have 2 ways, so that's why 2 times PQ, because they are the same. Okay, so the same thing, we look for the HH, so head and head, so meaning the first time is P, second time is also P, which gives you P square. Okay, alright. So for the second one, because we try to do more and more, so that's why I do not put in the tree diagram here. I hope you can try to imagine together with me. Okay, so the same thing, if I try to toss the coin for 3 times, then meaning that the possible outcome that I can have is like 0 head, 1 head, 2 head, or 3 head. Okay, so how many ways for me to obtain the success? So if I got 0 head, meaning I have tail. Okay, so if I have only 1 head, like 1 success here, meaning that I can have like tail head, or tail head tail, or even head tail. Correct? Okay, so the next one I have 2 head. So if I have 2 head, then I can have tail head, I can have head tail head, or I can even have head tail. Okay, if I try to draw the tree diagram, then this is exactly what I will get like if I continue to do it. Okay, then after that, the next one, if I have 3, then meaning that I get 3 times head. Okay, so how many number of ways? 1, 3, 3, 1. Okay, so what is the probability? You see T times T times T. So for you to get 3 times of T, meaning that the probability for each is like Q. So Q times Q times Q, you get Q power of 3. Okay, so for tail, okay, when you look at this one, right, you see tail times tail, you get Q times Q squared times P. Same thing, this one is Q times P times Q, and then P, Q. So when you try to times them together, right, you will realize that everything here, you actually get a PQ square. Is that okay? Probability for me to get a tail is Q. Probability for me to get a tail is another Q. And probability for me to get a H is P. So that's why PQ square. And everything is the same, isn't it? Like my T and H is still remain P and Q. So that's why it's going to be 3 times of 3P, square here. Okay, I have like 2 tail, and then for each of these, then I have 1 head. So the 1 head give me P, then the 2 tail give me Q square, and I have 3 ways here. Or meaning it's just like PQ square plus PQ square plus PQ square lah. Okay, so I do the same thing for here, then meaning I have 3 ways also. Then after that I have 2h for every of this, so meaning it will give me p squared and then times with the q. Okay, so h, then meaning I will have all the p power 3. Okay, so now I want you to try to find out what is the pattern that we can actually realize in the table that we actually built here. Okay, if you still remember, right, you see this distribution is called as binomial distribution. When you look at the number, I'm not sure whether you find it familiar or not, it's basically the same thing like what we have learned in binomial expansion, or the binomial sequence or the series that we have learned before, which all this is actually the Pascal triangle, or in another way it's basically about combination. How do you get 1 here? It's basically 2c0, 2c1, and this is basically 2c2. In another word, the 2 here basically meaning how many trials that we are doing. So like for this one, right, we do it first round, second round, meaning the coin is thrown twice. So the 2 actually come from the total trials that you actually carry out the experiment. Okay, so what is the 0, 1, 2 is basically your success. So meaning out of the 2 trial, I don't have anything that give me hate, so that's why 0. Out of the 2 event that I actually did, one of the number will give me a success, so that's why I put 1. So the other one I have 2. So after I find it out, then you can realize this is actually 1, 2, 3. Sorry, 1, 2, 1. Okay, so the same thing. This is throw 3 times, right? So that's why now the total trial here become 3. So this is basically 3c0, 3c1, 3c2, and 3c3. And this is how I get all the number of ways here. So meaning it's tally with the reality if we try to do it like manually without using the formula. Okay, so now let's try to see the probability here. What you can realize here is I use n2c0, right, which is 1. So 2c0, if I get 0 times of head, meaning the probability for me to get the p is basically 0. So that's why p0. 2c0 give me 1, p0 give me 1. Then because of I have 0 success, meaning I have 2 failure. So this is how I get q squared. Then I continue the same thing, 2c1. Out of the 2 trial, I get 1 head. So p1, q1, which give me 2 pq. So the same thing here, this will be 2c2, success 2 times, failure 0 times. This is how I get p squared. Alright, okay, next one. Same thing, 3c0, meaning I get 0 time of success, success 0, and then q3. So 3c1 here, and then I get 1 time of success, 2 times of failure. 3c2, I get 2 times of success, 1 time of failure, which give me 3p squared q. And then p q, that meaning I have 3c3, and then p success 3 times, failure 0 time, which give me p3. Okay, now we have find out the pattern already, right? Now we try to come up with the formula, or we try to do it once again. So why is binomial distribution helpful? You can always say that, you see, this one is basically what we have learned previously in independent event. So the idea is like, let's say if I am going to continue on with this, like this is 2 times, this is 3 times. If I want to continue this for 10 times, are you going to draw out the tree diagram and you are going to count out the ways of the success one by one? So it's like quite impossible for us to do that, like even though we continue for like 100 trials. So that's why we try to come out something like this, a distribution which we can try to see the pattern, and we use the formula to solve the question. Okay, so now with this, we try to put it in the other situation here. Okay, so now we have this already. So we try to use the pattern that we actually found out here and try to do it in a 4 times trial. Okay, so you see, just now we see this is 3C0, 3C1, 3C2, then this is 2 because this 2 times, this one 3 times. So that's why when I toss the coin for 4 times, then what I'm going to do? I'm going to do 4C0, 4C1, 4C2. Sorry, I should write this first. So the possible outcome for your R will be 0, 1, 2, 3, 4. So meaning the max that I can get a hit is at 4 times, or I can get a 0 hit and so on. Okay, so 4C3 and 4C4. Okay, then we try to come up with a probability, then later we use manual calculation to check whether everything is correct or not. Okay, so this will be 4C0. So I get 0 success, right? So P0 and then failure will be 4 times. So 4C1, probability for me to get success is 1 time and then 3. So 4C2, success 2 times, failure 2 times. So 4C3, success 3 times, failure 1 time. So 4C4, success 4 times, Q 0. Okay, so now we try to use check manually whether everything is correct or not. Okay, so what is 4C0 is 1, 4C1 is 4, 4C2 is 6, 4C3 is 4, 4C4 is 1. Okay, so now let's check whether we get all the ways or not. So for me to get 0 hit, I have only one way. What is the way? So meaning that it will be tail, 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 tail. Correct? One way. So yes, correct. So how do I find this? 1, 2, 3, 4. So probability for tail to happen is Q, right? So Q times Q times Q times Q, which give me Q power 4. So you see, this is correct. 4C0, 1, P0 is 1, so you're left with Q4, which is correct. Okay, so let's move on. So if I want to have 1 hit, then what is the possibility I have? I have tail, 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 hit. Okay, or I can have hit, tail, tail, tail. Or I can have tail, hit, tail, tail. Or tail, tail, hit, tail. Okay, only 4 ways. I don't have anything else, right? Yeah. Okay, so then after that, meaning when I try to draw the, what is that called? Your tree diagram, then this is what I will be having. Okay, so you can see everything you have 3 tail and you have 1 head. So you have 4 of them. So it will be 4. And then everything you have 1 head only, which is 1P. You have 3 tail, which is Q3. So that's why you see it's correct also. Okay, then we continue on for this one. For 2 times of head, then the thing that you might have is like tail, tail, head, 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 tail, tail. Okay, or head, tail, tail. Yeah. Then head, tail, tail, head. Or I can have like tail, head, and head, tail. And you can realize that we don't have any ways other than this anymore. Okay, so for everything here, you can see you have 2T and 2H, which give you P square and Q square, and you have 6 of them. When you plus them together, meaning you times 6. So this is basically what you get. Okay, so the same thing. So I'm just trying to do this real quick because I realized I used like quite a lot of time to explain this. Okay, so yeah, same thing. So this one is for you to get 3 head. So you can have head, 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 tail, tail, head, head, head. Okay, or you can have them head, tail, head, or head, tail, head. So 4 ways. So you can have 4 ways here. Then every of these you have 3H and you have 1T. Okay, which is what you have get here. Okay, so the same thing for the last one, for you to get 4 times of success, meaning head. Okay, which give you P power 4. So this is how you get it. Alright, okay, so now let's look on the formula. So from what you can realize here, right, you can see that actually why we are putting all 4 here and why we are putting 2 and 3 here. So it's basically like how many trials or how many times of experiment you have actually did. So that's why your formula will be something like, okay, I try to explain it in a paper so you can try to look at it by yourself. Okay, so yeah, everything that we did here is like 4, 4, 4, 4, 4. What is the 4? Is the coin is thrown 4 times. So basically this is your n. So n is like what is the number of trials that you have actually did. Okay, so n is number of trial. Okay, then after that everything we do combination, right? Okay, so what is the 0, 1, 2, 3, 4? So that's basically like how many time of success that you want, correct? So this is your R. Alright, okay, so your R is basically the number of success that you want. Okay, so in this way, it's like you want 0 success, so meaning 0 hit, 1 success, 1 hit, 2 success, 2 hit, and so on. Then after that, we try to do P. Our P is basically the probability for the success to happen lah. So P. Okay, P is probability for success. And then after that, what is the 0, 1, 2, 3, 4? Is how many success you have, right? So it's basically your R. You see 0, 0, 1, 1, 2, 2, 3, 3. Because when you want to say like 4C what, then that number is basically how many times of success you wish it to happen. So that's why you times the probability of success with that number. Then after that, your Q. Okay, Q is probability of failure lah. And then how do you get the Q? So like 4, 3, 2, 1, 0. So if you get 0 success, meaning you have 4 failure, how do you know that? Because you know that you are going to do 4 times of trial. So that's why this is n minus R. Okay, so like total, I do it 4 times. So if 0 times success, then of course 4 minus 0, I get 4 times of failure. So if I have 1 time success, in the total of 4 times, I get 1 success, meaning I have 3 times, which is 4 minus 1, and so on. So this is the formula that we are trying to use. So the full one, we'll write it like probability, okay, for the success equals to the number, it will be equals to something like this. Okay, so you can look at the notes, then try to put it in your try to like copy it or put it aside when you want to go through all the question together. Okay, so I have actually put in also the formula that will be given in your exam. So it's basically the same thing lah, but then because you already know that Q is the probability of failure, right? So in your what is that called? In your question paper, they write it in this way: probability for R. They don't write like this, but actually I think in this way is much more easier for you to answer. But I just want to make sure that you understand what they write. So equals to, so this one we have actually discussed previously in the class already. So it's the same thing. When I want to write NCR, instead of like NCR, I will write NR. So it's the same thing lah. Probability R, and then they don't use Q, they use 1 minus P. So basically it's like probability of failure is basically 1 minus probability of success, then N minus R. So these two is basically the same thing. It's like which one you are more familiar, and you can just use it like as familiar as you can. So normally in binomial distribution, we will try to write it in this notation, which is something like this. Okay, so X is your discrete random variable, so you can put anything as you want, like A, C, D, and so on, but don't try to use B lah, okay? So like anything that is no specific meaning and so on, you can try to put it. It can be P, it can be anything. So the B basically means binomial. This is the name or the variable for your discrete random variable. B means binomial. N is how many number of trials that you have did. Then P is your probability. Okay, so just like that. Alright, so you can go through all the notes by yourself. Then we will try to go through 6 examples together. Okay, so now let's look at our first example. Okay, I tried to put this in, you see in your what is that called, in your learning outcome, right? They didn't state that you actually need to learn the graphical representation, but then I think they assuming you to know also how to draw a bar chart and so on. So that's why I am not going to like go through with you like how to draw and so on, because it's like something that is like very common sense. But I just want to show you like 1 or 2 example if you have some question that come out like asking you what is the characteristic and so on, so you will be able to answer. Okay, Alright, so number 1, a fair coin is tossed 3 times in succession, so find the probability to obtain the head exactly 0, 1, 2 or 3 times. Okay, so this is very similar to the question that, to the example that we did previously, so I'm not going to explain like too much. Okay, so here meaning that we try to say that the success here, okay, we try to denote it is like the X is basically the event for you to get number of head. Okay, so meaning number of head is like our preferred event, so we try to set that the probability for the success here is basically referred to the number of head. So this is a fair coin, so meaning that the probability for me to get a head will be 1 over 2. So we try to write it in the notation that X, since we use X, right, so you can use anything here, like you want to use A, B, A, C, D, K, L, anything. Okay, so X is a binomial distribution with N, so you toss how many times? 3 times, so 3. And then your P is your probability for your success, which in this case is 1 over 2 lah. Alright, okay, so now we try to find it. So probability for X, probability for number of head equals to 0 first. Okay, X equals to 0. So we try to use the formula. Okay, NCR. So your N here is 3. So you do 2 times of trial, you expect to get 0 success. So that's why probability for P is 0, probability for Q will be 3. Okay? Then equal to, then 3C0, your P is 1 over 2, meaning your Q is 1 over 2 also. Then power of 3. And you just use your calculator to get your answer, which in this case you can get a fraction, which is 1 over 8. Okay, then do the same thing. Probability for me to get number of success or like number of head equals to 1, which equals to, out of the 3 times, C1, probability for success, power 1, then Q, total 3, right? 3 minus 1, you get 2. Okay? So 3C1, your P, Q, sorry, this is 1, then 2. Okay, so you'll be able to get 3 over 8. Alright, it's very important for you to, so if after you get it familiar, right, for this part, you can skip it, but for this part, you must write it. So you do not skip, like press everything in your calculator then get to your last answer, because in your exam and so on, there will be a part that they want everything stated clearly and simplified. So that's why this too is very important, that you must make sure you write, and make sure that you don't write like 3C0 equals to 1 or like anything that you have counted in para, because what happened is if you did it wrongly, then everything will wrong already. Okay, so probability for number of head equals to 2, then it will be 3C2, then you will put P2 and Q1. Okay, so 3C2, 1 over 2 power 2, 1 over 2 power 1 equals to 3 over 8 also. Okay, so let's move on for the last one. X equals to 3, so 3C3, then you have success 3, failure 0. So 3C3, 1 over 2 power 3, 1 over 2 power 0, which gives you 1 over 8 also. Is that alright? Okay, so now we will try to draw it in terms of like graphical representation. So which one you use is totally fine, because I don't think they will really ask you to draw the graph, but you might have questions that they want to ask you like what is the characteristic of your graph or so on. So that's why it's good if you try to know like a bit like basically how it looks like. Okay, so you can use 2 types of graph to represent this distribution. The first one is called vertical line graph, the second one is called a bar graph. So how do you draw a vertical line graph? So it's very easy. Okay, so for your horizontal line, right, you will draw your x, or in this term then maybe we put it as your r. Like you will write px equals to r, so that's why this is r. Then for your vertical line, it will be your probability. Okay, so after that you can, so now you can see what is the x that you have is 0, 1, 2, 3. So that's why 0, 1, 2, and 3. Okay, yeah, it's like not what is that called? This is like a graph that didn't show you like a real relationship in numerical way. So meaning like that doesn't matter that whether you start, so normally in for a bar graph or vertical line graph, we don't start with like the axis even this is 0, because this is discrete random variable. So sometimes we might have a negative number also, or sometimes we can have a decimal, or like sometimes we just start with 2, 5, 6, 7. So you can just write 2, 5, 6, 7. It's not important for the scale for your for your horizontal line, because you are not going to use this to predict anything like when x equals to what, then y equals to what, and so on. It's just basically a graphical representation. Okay, so you can see 1 over 8, 3 over 8, 3 over 8. Then maybe let's try to do this like 1 over 8, and then 2 over 8, and this is 3 over 8. Yeah, but then for vertical one, you still need to follow to the scale up, because you want to show like what's the difference or how's the distribution look like. So for 0 is 1 over 8, for 1 is 3 over 8, for 2 is 3 over 8 also, then you have 1 over 8. Okay, so this is how you basically show this is vertical line graph. So for a bar chart, right, then it will be something like this. Okay, do the same thing. But we are trying to draw a bar later. Okay, you can see that it's some of the book or like some of the videos, sometimes they teach you to draw with what is that called, with space between the bar, or like without space is totally fine, because it's just a bar chart. So like what I say is going to be a simple graphical representation. You are not going to use it for like further analysis to count out like what is the mode and so on. So it's just basically a graph. So both can be accepted, but normally we'll try to draw it without any space lah. Okay, so it will be something like this, 1 over 8, this is 1 over 8 also, and 3 over 8, 3 over 8. Okay, so it will be look like something like this. Okay, so this is a probability distribution graph. Yeah. Okay, but yeah, normally I don't think they'll really ask in exam, but they might ask you like how's the characteristic look like. So this is like the symmetrical one and so on, or like negatively skewed or positively skewed and so on. Okay, all right, so that's number 1. Okay, for number 2, so for this question, use 4 significant figure, and then yeah, try to write down the answer. Okay, so something that you need to bear in mind here is like for your exam, right, for your final answer, normally we try to write the answer in like 3 significant figure, but I'll recommend you for everything that you deal with probability, right, in the working itself, try to write at least a 4 significant figure. So when you plus them together, or you further use it for like the other calculation, or you want to plus them together, so you can reduce like the reduce the error that actually due to rounding. So that's why every time in your calculation, right, do it for at least 4 significant figure, and for your last answer only you change it to 3 significant figure. But it will be good if you want to write like 5 or 6 significant figure lah, but I think 4 is more than enough. So you just that to make sure that you have a line that is like unsimplified one before you move on to the last one. Or if you can set it with your calculator, you check every answer and get your last answer, that's like, of course that's better. Okay, all right, so number 2. everything use 4 significant figure here. 2% of the batteries produced by a factory are not satisfactory. So in a sample of 12 batteries chosen at random, find the probability that the batteries are not satisfactory is exactly 3. Okay, so in this question, you can see that a sample of 12, so meaning like you have a number of experiment that you are going to check. How many times you are going to check? You are going to check 12 times. So that's why your n is 12 here. Okay, so yeah, remember some of the constraint that I said. So like for the first time, your battery is 2% of it might be not satisfactory, but after you pick the first one, it's not going to affect the second one. So everything that you see here is basically independent, and you have only 2 outcomes, which is either is not satisfactory or is satisfactory. Okay, so that's why this is basically a binomial. So what we try to do is we try to we try to define first what is our success here. Okay, so maybe here, yeah, same thing. Normally we try to use x. Okay, so x is the number. Why am I using a pen? Okay, so x is number of batteries. So since this one you see, right, I said already there's no positive and negative about the success and the failure. Is basically what will be, which one you assign will be much more easier to help you to solve the question. So for this one, since the probability they want to find is like the battery which is not satisfactory, so we just try to put the success as the batteries that is not satisfactory. Okay, number of batteries which are not satisfactory. Okay, so now A. Alright, okay, so A is the probability that the batteries which are not satisfactory is exactly 3. So meaning probability when the number of battery not satisfactory is basically equals to 3. Then you can try to do your calculation. Yeah, so formula NCR, so number of sample that you have is 12 here. So 12 C 3. Okay, you want to have 3 not satisfactory battery. So that's why P3 and Q 9. Okay, so how do I get 9? It's like 12 minus 3. Or the other way, you just remember you have 3 success, meaning you have 9 failures lah. Okay, so it will be equals to, let's continue, 12 C3. So what is your P? The probability for the battery to be not satisfactory is 0.02, which is the 2% here. Okay, power 3, and then 0. How do you find the failure one? So 1 minus 0.02, which is 0.98. Okay, power 9. So you can straight away get your answer, 0.01467. Okay, so this question asks us to use 4 significant figures, so we use 4 significant figure. Okay, next one, move on to B. So the number of the batteries that are not satisfactory is less than 2. So probability for X less than 2. Okay, so for less than 2 meaning that what is the exact what is the number of batteries that's satisfactory that you can accept? So it's when Px equals to 0, Px equals to 1. Okay, can you accept Px equals to 2? No, because you want less than 2. So that's why only 0 and 1. Okay, so for Px equals to 0, then it will be 12 C0 P0 Q12 plus 12 C1 P1 Q11. Okay, so now you can try to substitute the P, which in this 0.020, 0.9812 plus 12 C1 0.021, 0.98 is 11. Okay, so you try to get your answer from your calculator, you will be getting 0.021 0.7847 plus 0.1922. Okay, we should give still answer 0.97969. Okay, so that is for x smaller than 2. Okay, so now let's move on for C, at least 4. So at least 4, what does that mean? So meaning that you accept anything that is greater or equal to 4, which is at least 4, right? So x greater or equals to 4. So you realize that if you want to solve it like this, then you need to find out 4, 5, 6, 7, 8, 9, 10, 11, 12. So there is a lot of things that you want to find. So instead of doing that, then what you can try to do is you use 1 minus p x smaller than 4. So you need anything that is greater or equal than 4, meaning that you don't want anything that is less than 4 basically. Okay? So equals to 1 minus, then you can use the answer that you have previously to help you to find the answer. Okay? So you use 1 to minus x equals to 3. Okay? And minus px equals to 2. So since you have this one also, then okay, you can write it down first, then later you try to use the answer that you have in B to help you to get the answer. Okay, sorry, I write here a bit. Okay, so 1 minus, so probability for you to get 3. So how do you find that? Yeah, you have the answer from your A. Okay, so 0.001467. And then minus probability x equals to 2. Do you have anything? No. So you need to find it out. 12C2, your P, 0.02 times power 2, 0.98 power 10. Okay? And then minus x equals to 1 and x equals to 0. You have found it in B, right? So you straight away use it here. Okay, so you use your calculator to get the answer, then you will be able to get 0.000063. Alright, okay, I hope that you can get it until now. So let's move on for the next one. Okay, number 3. A box contains red and green marbles in a ratio 1 to 2. 5 marbles are taken out from the box one by one with replacement. Okay, after next marble is drawn, find the probability, blah blah blah. Okay, so you can see in this question they have like 2 marbles here, so meaning you only have 2 outcomes here, which either you get a red one or you get a green one, which is good for a binomial distribution. Okay, so now let's try to do this. Okay, so for this one, since A, yeah, you can see that A and B, they are asking the different things. So for this kind of question, you need to be like extra careful that you do not want to mix up or confuse by your success and your failure. Okay, so since the A is asking about the rate and we are trying to do the A first, so we try to state that the number of success refer to the number of getting a rate first. Okay, so yeah, for A. Okay, so you want to get a rate one, so maybe let us just do it for the x. So x is basically number, okay, getting a rate or number of rate marble lah. Okay, number of rate marble. Okay, so now we can try to continue it. Exactly 4 are red, so meaning that probability for number of red equals to 4 equals to what? Okay, so NCR, what is your N here? 5 marbles are taken, so meaning in total you have 5. So 5, C, 4 is going to be red, so that's why P4, then Q1. So meaning 4 red and 1 green. Okay, then after that equals to, so 5C4, P is, what is the probability? So you see, the question actually didn't give you the probability and they did not give you what is the total marbles in the box as well. But you see, every time when we try to do probability, right, let's say I have a total of 40 students in the class, then girls are 20. So we can say that the girl is half. How do you get half? It's like 20. Sorry, I try to say it again. Okay, let's say you have 40 students in that class, so 20 of them are girls. So when you try to find out the probability, then it will be 1/2. So how do you find out 1/2? Is basically 20 divided by 40, then you simplify your fraction, then this is how you get 1/2. So that is all about ratio. So if ratio of getting a rate is like, sorry, I think it's a bit annoying with the motorcycle outside. Okay, so yeah, the rate is like 1 over a total of 3. So meaning that the probability for you to get a rate is basically 1 out of 3. Do you get it? So like the ratio for red and green is basically like for you to get 1 red, you need to get 2 green. So like the ratio is like they are double of green marbles in the box than the red color. So we are trying to do it like 1, 2. So that's why the probability for you, the ratio for you to get a red color in the box is basically 1/3. Okay, I hope you can get it. So meaning that I try to put it if I 1 and 2, right? So meaning in a total ratio I have 3 color. So 1 out of the 3 will be red color. 2 out of the 3 will be green color. So this is what is that mean. Okay, so 1/3 power 4. So for green color it will be 2/3 power 1. Okay, so when you times them together, then you will be getting equals to 10/243. So anything that you can still write them in a fraction, then you just write in a fraction, then they will give you a more accurate answer. Okay, so that's for A. Okay, B. More than 2 are green marbles. Okay, so you see, can I write this question as Px greater than 2? No. Why? Because my x is the number of red marble. If I write Px greater than 2, meaning that I want to find the probability more than 2 are red marble. But now I want to find more than 2 are green marble. So we need to think it in another way. What is that mean to red marble if you say that more than 2 are green marble? So if more than 2 are green, what does that mean? It means less than 3 are red. Do you get the idea? Okay, more than 2 are green, so meaning that 3, the green must be 3, 4 or 5. Correct? So 3, 4 or 5. So meaning for my red, if at least 3, so meaning like you can have, okay, if you have 3 green, then how many red that you have? 2. If you have 4 green, then how many red that you have? 1. So if you have 5 green, then how many red that you have is 0. So basically more than 2 green, it means less than 3 red. Do you get it? Yeah, it's like the total is like 5 white. So more than 2 green meaning that less than 3 is red lah. Okay, so you can find it out by using probability for x less than 3, so smaller than 3. Is that okay? That's the first way that you can do. Okay, so meaning after this, then you will try to find Px equals to 2 plus Px equals to 1 plus Px equals to 0. Okay, so I'll write down like very quickly. So NC2, your P, Q plus NC1, P, Q, and the last one 0, 0, and 5. So you'll be getting your last answer as 64/81. Okay, question. If I don't want to do like this, like I find it very confusing, if I were to change the idea for more than 2 are green to less than 3 is red, then what can I do? Then I try to denote my new success again. Okay, so if you think that it's very hard for you to think for the red than the green one, then you change it. So meaning I try to use a new one, then maybe I try to write let y, so this is all. Okay, so or you can do y equals to number of green marble. Then for this case, you have the opposite way for the PQ here already. So meaning now your success become a green color. So meaning your P will become 2/3. Then your Q will become 1/3. So for previously, the success is 1/3, right? The failure is 2/3. So now when you try to change it to the failure become success now, so now you have the other one. Then you can just do it like what I have stated in your question. More than 2 are red marble, meaning y, then more than 2. Okay, then you can straight away get your answer by using this also can. So when you realize when you write out the whole thing, right, you actually get the exactly same thing like what you have done previously also. So it's just like depends on you, like which one, sorry, this should be y. Okay, it just depends on which one you prefer to use. So both method can be accepted, but just make sure that when you try to denote the other variable is it must be a different one with a, then you need to state it clearly that what is the y here. So do not like without this sentence then you are going to write py greater than 2 because no one knows that what you are trying to do. So you need to assign yourself and then state it clearly that what is that mean by your x and y, then only you continue your working. Okay, so both can be accepted, and this one you should be getting the same answer also, so you can try it out by your own. Okay, alright, number 4. 20% of the total shots fired by Andy hit the target. If 10 shots are fired, find the probability that at least 8 shots fail to hit the target. Okay, so this question is the same also. The question actually give you 20% hit the target. A asks you what is the probability that they fail to hit the target. So it's the same thing, like depends on you whether you want to say like which one is your success, which one is your failure. Okay, so okay, so normally I'll prefer to refer back to the question, so you can see that for A they asking like fail to hit, but for B they ask you like the probability of hitting. So it's the same thing if you want to denote like 1x and 1y again like the number 3, or if you don't want, if you think that you can try to change another way of thinking, then just try to denote 1 and try to go with that flow. Okay, so for number 4 I'll try to use this method instead of like denote like 2. Okay, so 20% of the total shots fired by Andy hit the target. So if the 10 shots are fired, find the probability that at least 8 shots fail to hit the target. Okay, so what I will try to do here is A. Okay, so I'll still try to do hit the target because there will I will find it like easier for me to solve the B question later. Okay, so meaning now what happened is like x will be equals to number of shots okay hit the target. Okay, so if x is the number of the shots hit the target, then what is the probability for my success? 20% hit the target, right? So meaning my P is 0.2. So what is my Q? My Q will be 1 minus 0.2, which is 0.8. Okay, so now if 10 shots are fired, find the probability that at least 8 shots fail to hit the target. Okay, try to think it in this way. If at least 8 shots fail to hit the target, what is that mean? Okay, at least 8 shots fail to hit, meaning at most 2 shots hit the target. Okay, so you see, at least 8 shots fail the target, meaning I have 8 shots fail to hit, I have 9 shots fail to hit, I have 10 shots fail to hit. So meaning that I only can in this statement in another way, meaning that I hit the target for 0 time, I hit the target for 1 time, and I hit the target for 2 times. This is how I get 10, 9, 8, right? For the one that failed to hit the target. So at least 8 shots failed to hit the target. At least 8 shots failed to hit the target is basically equals to at most 2 shots hit the target. Okay, I hope you can get this idea. You can try to write it out loud and try to think it again. Okay, so probability for at most 2 shots hit, so meaning that smaller or equals to 2. Okay, so it will be equals to probability that none of it hit 1 or hit 2. Okay, so now let's try to write everything. Okay, so this will be n 10 shots, so n c 0, probability for me to hit is 0.2, 0, 0.8, 10, and then plus 10 c1, 0.21, 0.2, sorry, 0.89. Now I plus the last one. Oops, I'm sorry. I hope that you can see this clearly, because I scared that later I don't have enough space here. Okay, so I have 0.1074 plus 0.2684 plus 0.3020. So again, I advise you to at least use 4 significant figures in your process. Then for your last answer, you only change it to 3 significant figures to make sure it's more accurate. Okay, so B, find the minimum number of the shots that Andy must fire such that the probability of hitting the target at least once is more than 0.85. Okay, so this question is a little bit different now. Find the minimum number of shots, so meaning that I do not know how many shots Andy have taken. So meaning like, what is my n? You need to find out the minimum n that you must shoot lah, basically. Okay, so B, try to write this in a mathematical way. So Andy must be fired so that the probability hitting the target at least once is more than 0.85. Probability for the number hitting the target must be at least 1. So how to write at least 1? So more than or equals to 1. This is what is that mean by at least once, right? So more than is more than 0.85, more than 0.85. So now only you try to solve this. Okay, so how do we solve this? So you can see here, if you want to go for this way, then what will be happen is you need to find px equals to 1, px equals to 2, 3, 4, 5, 6, 7, 8, 9, up to until you get the n. So which is quite impossible because we don't know what is our n here. So do we have another easier way to do that? So instead of doing 1 to n, then we try to do 1 minus the one that we don't want. So meaning in this case, what is the condition that we actually don't want? Is like I have nothing hit. Correct? I hope you can get it. So greater or more than, sorry, at least once, meaning that I do not want the situation which I have hit 0. So basically I use the complete one, which is the probability 1 to minus the px equals to 0. Then greater than 0.85. Okay, so now we try to do it. So 1 minus, I do not know what is my n. So this will be nc0. So the probability for my pq is still the same, right? So 0.20 and then 0.8 will be n. Because n minus 0, I get n. So 0 times of success, meaning n times of failure. Okay, so greater than 0.85. So now we can try to move it around. So NC0 you get 1, 0.2 power 0 you also get 1. So you're left with 0.8 power n. So you can move it, like change the place. So 1 minus 0.85 greater than, this is minus, right? So I put it to the other side that I have a positive. So 0.8 n. Okay, then after that I have 0.15, 0.8 power n. Okay, so how do we solve this? Yeah, you need to use your knowledge in log. Okay, so log 0.15 greater than n log 0.8. I hope you still remember how to change our log, then you can bring down your power. Okay, then after that, bring your log to another side. Okay, something you must be very careful in this type of question is that you need to check out, because whenever you do inequality, when you divide or multiply by a negative number, you need to change the sign. So because it's log, so we cannot see this like very clearly, so you need to use your calculator to find out what is log 0.8 first. So if that log number give you a negative number, then you need to switch the sign. Okay, so meaning log 0.8, you check with your calculator and you will be getting a negative number. So because of the negative number, now we need to change the sign. So log 0.15 divide by log 0.8, so we need to change the sign and n. So you'll be getting n greater than 8.50. Okay, so we cannot say that like you take a short of 8.5 times of the short. So the minimum number of shots that he must take is equals to 9, because it must be more than 8.5. So that's why the minimum n is equals to 9. Okay, so basically like he need to shoot at least 9 times, so that the probability of hitting the target at least once is more than 0.85. So it's basically like as long as you hit more than 9 times, then most likely you will be getting hit. You will be hitting the target lah. Okay, that's like very common sense or something that you should be understand when you try to answer the question. Okay, that's it for 1, 2, 3, 4, which is basically more on like the application part. So for last two questions, it's actually very easy one. I just want to go through with you the notation and so on. So that's why I try to like cover everything more than, less than, at most, and so on in the previous 3 questions, so that I do not want to do repetition, so to lengthen the video. Okay, so number 5, k is a variable. It's basically a discrete random variable that you give to the question. So b meaning binomial, 12 is the n that you have, and then 0.2 is your p. Okay, so you want to find out probability when k equals to 3. Okay, so which is very easy. So what is your n? Yeah, if you scared that you forget, then you can try to write it out. 12 meaning the n. Okay, then 0.2 is your p. Okay, so probability for k equals to 3, meaning that total is 12, and then c equals to 3. Okay, then p3, so q9. Then it will be equals to 12c3, p is 0.2, power 3, and then q is 0.8. Okay, which is your 1 minus 0.8, so 9. So you will be getting your answer, which gives you 0. Hold on. Okay, 0.236. Okay, so B, probability for k smaller or equal than 3. So it will be p k equals to 0, pk equals to 1, plus pk equals to 2, plus pk equals to 3. Okay, so now we try to expand it. So probability for k equals to 0, meaning out of the 12, c0, p0, q12, plus 12c1, p1, q11, plus 12c2, P2 Q10 plus 12 C3 P3 Q9. Okay, then you put it in all your, what is that called, your P and Q. Okay, so your P, Q, okay, so yeah, by this time you should be able to do this already. So I'm going to write down because this is exactly what I get. But we try to write in for significant figure because we use the number to do the calculation. Okay, so again, please try to do not use your calculator to get all your answer. If you are already very familiar with this, skip the second line. So meaning this line. Okay, but the one that you putting all the number, the substitution part for this line, you must have it in your exam. Okay, so after that you can write down your answer. So 0.09872 plus 0.2062 plus 0.2835 plus 0.2362, which gives you three significant figures 795. Alright, okay, so number 6. Given that discrete random variable t in a binomial distribution with n is n, probability of success is 0.4, and that probability for x equals to 0 is smaller than, oops, I'm sorry, I think I did some typo here. It's okay, I'll change it in your handout. So pt, okay, is smaller than 0.1. Find the least possible value for n. Okay, so this question is like similar to the question that we have did just now, the minimum number of shots that we did in question 4. Okay, so this is much more easier because they already give you everything, like it's like basically you do not need to model the distribution by yourself. Okay, so probability for you to get t equals to 0 is smaller than 0.1. So you solve it. So how do you find it? Then the same thing, probability t equals to 0, then how do you do that? Then it will be n, c, 0, p, 0, q, n again. Okay? So yeah, because n minus 0 you get n, that's smaller than 0.1. Okay, then you can continue, nc0, p0, which gives you 1, then qn. So what is your q? If your p is 0.4, meaning your q is 0.6. So if you want, then you can try to write it again. Okay, so meaning 0.6 power n smaller than 0.1. Okay, then we do log again. Okay, so and again check with your calculator. I think this one you get a negative also. As long as the number is smaller than 0, you will get smaller than 1. Yeah, smaller than 1, then you should get a negative log. So you need to change your sign also. Okay, so you will be getting for this question is 0.4.51. Okay, so the least possible value for any value, any number that is greater than 4.51, you will get a probability smaller than 0.1. So that's why your least possible value, okay, the least value for n will be equals to 5. So the first value that is greater than this range is 5. Okay, so I hope that you can understand. I'm sorry that I think the explanation wise takes me like quite a lot of time because it's something new, so I hope that you can understand. But if you find it like very slow paced, then just try to like watch it in like 1.5 or like 2 times speed. Okay, so for the Wednesday lesson, we'll try to go through for the expectation and the mean, which is very short part. Then we'll try to see the partial question for this. So I hope that you can understand. So try to go through all the exercise together. All right, thank you.